In this video, we're going to do Chapter 2 in the geometry book entitled Congruent Figures, Areas, and Volumes. So here, right over here, is an example of congruent figures. So figures that are congruent are exactly equal. And this is the symbol for congruent. We're going to cover this in the chapter, but this is the symbol right there. Okay, so this is telling me that triangle EDF, and this is a little light, so this is EDF, is congruent to triangle, and this is BAC. If they're congruent, it means that they're exactly equal and that all the angles are equal to each other. So E equals B, angle B. Angle D equals angle A, and angle F equals angle C. And all the sides are equal. So if they have one hash mark on this side, it equals the one with one hash mark on this side. 2 hash marks on this side equals 2 hash marks on this side. 3 hash marks on this side equals 3 hash marks on that side. So that will be discussed later, but I just wanted to give you a little bit of an overview. Here are shapes that we're going to calculate the volume of. So they had to be 3-dimensional shapes. Volume is a cubic, is a raised to the power of 3 measurement. Area is a flat surface, so it's length times width, so it's only 2-dimensional. And here are some of the shapes that we're going to calculate the area of. So that moves us on to the next page. Okay, on this page we talk about congruent triangles. We just did a little intro to that on the previous page. So 2 triangles are congruent if their corresponding sides are equal in length, in which case their corresponding angles are also equal in measure. So we kind of went through that a second ago. You can say the same thing about other shapes that are polygons. You can have a congruent polygons, and in that situation, just like for congruent triangles, all sides are equal to each other as they correspond, and all angles are equal as they correspond between one shape to the other. So if you open up the PDF version, you can click in here, and this is a very good website. It's called Math is Fun, and it'll let you play around with the idea of congruency. So one other thing, or 2 other things I guess I want to tell you about congruency, is if we're trying to prove it between triangles, and we will not do a whole lot of this. The way you can prove triangles are congruent is by these axioms. Side, side, side equals another side, side, side. So these are all triangles. Side, angle, side equals the other triangles, side, angle, side. Angle, angle, side equals the other triangles, angle, angle, side. Angle, side, angle equals the other triangles, angle, side, angle. And HL is reserved for right triangles, and that says that if the hypotenuse and leg of one triangle is equal to the hypotenuse and leg of the other triangle, they are congruent. Things that we can't use: if you prove that 3 angles are equal, you have not proved congruency. You've proved similarity, but that's for another day. You cannot use side-side angle. That won't do it either. So we're going to talk more about this in the future, but I just wanted to give you this introduction. And I strongly suggest that you go into Math is Fun and explore that a little bit about congruent triangles. That brings us to the next page. Okay, in this slide, we talk about the ways of classifying triangles. So there's 2 basic ways. You can classify them by their sides or by their angles. Okay, so if you classify them by their sides, you can say you have an equilateral triangle, and that means one triangle has all 3 sides that are exactly the same. You can say you have an isosceles triangle. Now, I'm going to have a little caveat for this, and that's why that little star is there. Isosceles triangles, by definition, not this definition, but this definition, they have at least 2 equal sides. So that means that equilateral triangles are also isosceles. Equilateral has 3, isosceles has at least 2, So it can have 2 or 3 equal sides. Scalene triangles have no equal sides. So let's take a moment and look at the hash marks. So for equilateral, what I'm seeing is that I have the same type of hash mark on all 3 sides. Since they all have double lines on them, those are called hash marks. That's telling me that each side is equal to the other. Isosceles, they gave the example of having 2 equal sides, but remember the definition is it has to have at least 2. And notice that you have only these 2 that are equal. Notice that in the scalene you have no markings. Your other option is to do this. Why don't we mark this with a single, with a double, with a triple? That certainly indicates that the measurements of each of the sides are different. And I would suggest that if I ask you to mark up a scalene triangle, you need to have marks on it. And those are the kind of marks that you have. No one mark repeats, and therefore no one side length repeats. Okay, so then let's talk about classifying triangles by their angles. Okay, so a big thing to remember is that every triangle has 180 degrees. So each triangle is going to have 3 angles that will sum up to 180 degrees. Okay, an acute triangle has all 3 angles less than 90. So think about acute being cute and little. Okay, so all 3 angles are less than 90 degrees. A right triangle only needs to have 1 right angle, and we would denote a right angle by the little box in the corner. Obtuse triangles have to have 1 angle that's greater than 90. So this angle right here is greater than 90. So for an acute triangle, you have to have all 3 that are less than 90. For a right triangle, you have to just have 1 that's equal to 90. And for an obtuse triangle, you have to have 1 angle that's greater than 90. Okay, another sideline that's rather important is that if you have equilateral triangles, those triangles have to be equiangular as well. So if a triangle has equal sides, it will also have 3 equal angles. And the book goes into detail about this. But you definitely want to know this because that's important. Okay, so that will take us to the next slide. Okay, this next slide is just something I'd like you to know about. We're not going to do a lot of work with this. But a relation on a set S is said to be an equivalence relation if it satisfies the reflexive, the symmetric, and the transitive laws. So reflexive means that A equals A. Okay, so A equals itself. So that's pretty basic. Okay, symmetric law is that if A equals B, then B has to equal A. Okay, one relationship implies the other. The transitive law is if A equals B and B equals C, then A will equal C. All right, so it's kind of like a leapfrog type thing. Notice I'm saying equals when you really have this other symbol. So you can say equals if that makes it easier for you, because that's totally fine. But what it's saying is if you have reflexive law and that follows through, that's true, and the symmetric law is true, and the transitive law is true, then you have a congruence situation. You have an equivalence situation. So the congruence of segments, angles, and triangles are all examples of equivalence relations. Other equivalence relations include equality of real numbers and similarity of figures. So just know what these words mean. In terms of the symmetric, think of this. If A equals 10, that implies that 10 equals A. Okay, that's symmetry. Transitivity, you have to have 3 things involved. Okay, so what if you say if A equals 5, okay, so A equals 5, and if 5 equals C, then do you see how you can definitely draw the conclusion that A will equal C? So if A equals 5 and if 5 equals C, then therefore A equals C. So transitive, you have 3. Symmetry, you have 2. Reflexive, you have 1. A equals itself. Okay, so just understand that vocab and then you'll be good to go. Okay, let's move on to the next slide. Okay, understanding exterior angles and remote interior angles and their relationship is important. We have this little activity here, which I strongly advise you to do. In fact, I believe, yes, I'd like you to do that. You can run through it. It's a math game, and it'll help you to understand the relationship. But let me just tell you about the relationship. So I'm going to draw another triangle right here. Okay, and I'm going to put some numbers in this triangle. So let's say we'll make this, let's make this 40. We'll make this, I don't know, let's make this, we'll make it 90, okay? So 40 and 90, that makes this one 50. Okay, so a couple of things are happening. This angle, when I extend the side, I get a straight angle. That's a straight line. That means that 50 plus this other angle right here is going to equal 180. So if that's the case, this angle that I'm pointing to equals 130. Okay, now let's talk about this. Let's use some words now. Angle A, which is right here, is my 130. Angle C and D, which are these angles right here, those are my interior far away angles. So they're remote. So they're my remote interior. So this box right here tells me that if I add C and D together, I will get A. So that tells me the theory. Now in practice, look what we have. If you add 90 and 40 together, you get 130. So the sum of the remote interior angles, which is the 40 plus 90, does indeed equal the exterior angle, which is 130. Okay, so think about that. So new things we know. A triangle has 180 degrees inside. 3 angles add up to 180. And a straight line has, let's make it into 2 angles, has 180 degrees as well. Okay, so think about that. I want you to practice that with this little game that I just circled, and we're going to talk about it more on the next slide. All right, so this should be saying exterior angle inequality. I cut off the E there. But in this little slide, we're going to continue our discussion of exterior and interior remote. So if I look at this triangle, if you extend the bottom part of the triangle, you end up forming an exterior angle. So the exterior angle is angle number 4. Okay, so then we have 2 remote, which means far away from the exterior angle, remote interior angles. So there are 2 of them. Okay, one is number 2 and one is number 1. So this is telling me that the exterior angle has to be greater than number 1, and it also has to be greater than number 2. Well, that makes perfect sense, because don't we know that angle 4 equals angle 1 plus angle 2? So since angle 4 equals that sum, then angle 4 has to be greater than either part of that sum. So it makes sense as a corollary to the exterior angle and remote interior rule. Okay, let's go on to the next slide. Okay, we talked about the word scalene before. So scalene is a triangle that has no sides that are equal to one another. So you have to mark them with different hash marks. So you can see right here we have a single hash mark, a double, and a triple. So that indicates to me that this is a scalene triangle. No sides are equal. Okay, the result of that is that no angles are equal either. All right, so you have to have equal lengths of sides to have equal respective angles. So scalene triangles, it talks about the length of the sides being unequal to one another, but it also results in angles being unequal as well. So with that in mind, we're going to go to the next slide where we're going to relate sides and angles and put them in order from greatest to least. Okay, so when we're relating sides and angles, the largest side is always opposite the largest angle. The smallest side is opposite the smallest angle, and the medium sized angle is always opposite the medium-sized side. Okay, if two sides are congruent, then the corresponding two angles across from them will also be congruent. So look what happens. Here is an isosceles triangle because it has two equal sides. Across from this side is this base angle. Across from this side is this base angle. Since the angles are the same, since the sides are the same length, the angles will be the same size as well. So what if we did this? I think we're just going to do a triple. This is a basic 3, 4, 5 triangle. I'm going to label the sides with letters, the angles with letters, and the sides will get labeled with the small version of that letter. Okay, this is the convention with labeling triangles. Okay, the vertices or the angles get the capital letters, and across from the angle gets the small version of that capital letter. So I'm going to say for this triangle, let's list the sides listed from, what did I say? From smallest to largest. Okay, smallest to largest. So I could say that A is across from, let's see, no, it's B. Sorry, so B. So let me erase that. So the smallest side has to be B. So B is less than the next one in order, A, which is less than, and I'm going to beg forgiveness again. I'm going to do my, well, yeah, I guess I can do this. Don't mind me. These are sides. So side B is less than side A, which is less than side C. So side C is the largest side. Given that, what do you know about your angles? You know that angle B, opposite the smallest side, has to be less than angle A, that's the middle side, which has to be less than angle C, which is the largest angle. So this C, we'll make that super big, okay, because the one above it, this pertains to the side, so we'll make that super little, okay? So that's how sides and angles relate, and this is a very important concept. Okay, in this slide we have some more vocab. So the midpoint of a segment, okay, so D right here divides this segment AB in half. So therefore D is considered the midpoint. So the midpoint is D. Okay, what's the perpendicular bisector? So the perpendicular bisector of segment AB is CD. So CD is a line too. So since it's a line, we're going to write it like that because it has arrowheads. So line CD has two roles. First, it's perpendicular to line segment AB. That's the first rule. And the second rule is that it bisects. And when it bisects segment AB, it divides it exactly into two equal pieces. So you want to know that. You don't need to prove it. You want to just have a working knowledge of that vocabulary. Okay, this is an important slide about polygons. So it states that polygons, some important formulas regarding internal angles. So first off, a polygon is a many-sided closed figure. Okay, so the sum of all the angles in a polygon is always equal to, and you want to memorize this formula. So these are formulas that you need to commit to memory. So n minus 2 times 180. That's the sum of angles in a polygon, and n is the number of sides. So let's try it with a triangle. Here's a triangle. The sum of the angles is going to be 3 sides minus 2 times 180. That equals 180. And we know that there's 180 degrees in a triangle, so that affirms that relationship. I then give you another example with a pentagon, and a pentagon is a 5-sided figure. And so if you plugged in 5 minus 2 for the pentagon times 180, you should be getting 540 for the total number of degrees inside a pentagon. Okay, now this word regular. Regular means that all angles and all sides are exactly equal. Okay, so that would be like an equilateral triangle. Okay, so if you have that case, then you could not only tell me the sum of the angles inside the polygon, but you can tell me each one because they'll all be the same. So take your sum and divide by n. So we'll try a triangle. Okay, so that's going to be n is 3. Okay, so n equals 3 for triangle since n is number of sides. So 3 minus 2 times 180 divided by 3 should give me 60. So if you have an equiangular or equilateral triangle, you will have 60 degrees in each of the corners. Okay, and then I go through an example of a pentagon. So you want to memorize that formula. I always find it helpful to memorize it in terms of a triangle, because if I test out a triangle, I can know whether I have used the formula correctly. And then the idea of regular, you're going to have equal angles, so just divide by n, and you have each angle. So let's go on to another important thing with polygons. Okay, so polygons, to continue our discussion, we can also talk about the relationship between an interior angle and an exterior angle. So exterior angles are formed when you take, so we'll make, I don't know, another quadrilateral like this. If you take a side and extend it, you form an exterior angle. Okay, so that's an exterior angle. So you can do it to every side. Okay, so here's another exterior angle. Here's another exterior angle. And here's another exterior angle. All right, so you have 4 sides, you'll have 4 exterior angles. If you have 6 sides, you'll have 6 exterior angles. The exterior angles are always going to sum up to 180 when you combine it with an interior angle. Okay, so the interior plus the exterior will equal 180. Why is that? Because they will form on a straight line. Straight lines have 180 degrees. Another important piece is this. If you add up all of your exterior angles, okay, exterior, 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 so that's a pentagon, the sum will always be 360. So that's important to remember. Okay, so that the interior and the exterior angles are supplements, which means they add to 180, and that all the exterior angles sum to 360 degrees. Okay, if this math is fun, it's another good thing to work through. You can get there by clicking in the PDF of this PowerPoint show that's posted on Joule. Okay, let's go on to the next topic, which is parallel lines in 2.2, which is very, very important. All right, parallel lines, hugely important. If you have parallel lines, so here's the parallel lines here and here, and if they're cut by a transversal, that's your transversal, angles show up that are pairs, that have relationships. So there are some words you need to know about that. Here are all the words. This is a good activity. This is a worksheet that I want you to do. I've posted that worksheet on Joule for this day too, and I've also posted the answer key. So a couple of little things that I'm going to point out. I'm going to draw my own parallel lines here and here. If I give you one angle, so let's say I say that this angle right here, is 40 degrees. Okay, this is a vertical angle down here. That will make it also 40. So vertical angles are always equal. Okay, vertical angles are kind of across the vertex. They're vertical. Okay, 40 and its partner next to it have to sum to 180 because they're supplemental. Okay, 140 has another vertical angle here that's 140. Okay, so then we have other things going on. Alternate interior angles are equal. Inside the two parallel lines are interior. So the 40 alternates with this 40 here. The 140 alternates with this 140 there. Then you can go back up to verticals and fill in the rest. So usually what's going to happen is that if I give you one angle, you can find the remaining 7 angles. This is a really important topic. You need to know all these vocab words. So spend time doing this activity, check your answer, and look in the textbook for this as well. Okay, because this is already so long, I'm going to stop this recording here, and we'll have a part 2 that will begin with the angle sum theorem. And actually what I may do is some more parallel lines on video 2 for this chapter. So this ends this one. I will post it, and there'll be a second one to go with the rest of the presentation.